Problem number 5. A swimmer swims at the speed v relative to still water. A river flows from a pier to a lake with the speed u. If the swimmer swims downstream from the pier to the lake, then back upstream, what was the average speed during the trip? Solution for problem number 5. To find what is the average speed, we have to divide full distance over full time. Suppose that full distance is d. In that case, total time to swim downstream will be t plus equal d over v plus u. The total time to swim upstream will be t minus equal d over v minus u. It means that average speed will be total distance over total time, which is 2d over t plus t minus. After calculations, d is cancelled, and finally we have v square minus u square over v, which is answer E, and that was solution for problem number 5. Problem number 6. A block of mass m is at rest on a frictionless table. It is pushed horizontally by a constant force F and has a total momentum P when it reaches the end of the table. If a block of mass 2m is pushed across the table in the same way, also starting from rest, what is its momentum when it reaches the end of the table? Solution for problem number 6. Since the forces and the distances are the same, the total work done is the same. It means that total kinetic energy is the same, and the kinetic energy is related to momentum by formula K equal P square over 2m. It means that for constant kinetic energy we have momentum must be proportional to square root from mass. It means that new momentum for mass 2m equal square root from 2p, which is answer D, and that was solution for problem number 6. Problem number 7. Two blocks of unequal masses big M and small m are hung from the ends of a massless frictionless pulley as shown. The blocks are held in place and the entire pulley is mounted on a sensitive scale. After the blocks are released from rest, but before either has fallen off the pulley, what is the scale reading? Solution for problem number 7. When the blocks on a pulley are released, both blocks accelerate, with the heavier block accelerating downward. It means the center of mass is uniformly accelerating downward, which means the force acting on the pulley is less than weight big M plus small m multiplied by G. That's answer A, and this is a solution for problem number 7. Problem number 8. A ball is launched with the speed v at an angle theta to a fixed ramp, which itself makes a 45 degrees angle with the horizontal. Assume that when the ball hits the ramp, it bounces elastically and frictionlessly. For what value of theta will the ball bounce off the ramp 2 times and then return to its original launch point? Solution for problem number 8. First, let's use another coordinate system, which looks like this. Axis x going to incline and y going perpendicular. In that case, we have new initial velocities and new accelerations due to gravity. We have Vx equal v cosine theta, Vy equal v sine theta, Ax equal negative g over square root from 2, and Ay equal negative g over square root from 2. First, for both directions, we can count total time to travel. If ball is hitting 2 times to this incline before it returns to the initial point, it means that it traveled 3 times to up and down. It means that total time to travel equal 3 times change of vertical velocity, which is negative 2 Vy over Ay, which is 6v sine theta over g over square root from 2. From other hand, when this ball returns to original point in coordinate x, it means that total change of speed equal negative 2vx, and the total time to travel equal negative 2vx over ax, which is 2v cosine theta over g over root 2. Now we have to equalize this 2 times, from which we can find that tangent theta equal 1/3. It means that theta approximately equal 18.4 degrees, which is answer E, and that was solution for problem number 8.